Good afternoon, ladies and gentlemen. We are going to go ahead and view your recording here. This is lesson 2-5. We're still doing some more practice on absolute value equations, but before we do that, we are going to go ahead and complete this warm-up. All right, so number one, a hang glider 25 meters above the ground starts to descend at a constant rate of 2 meters per second. Which equation shows the height h after t seconds of descent? Well, the first thing that I need you to notice is that this says we are going to descend, which means we are going to go down. Okay, so whatever equation I choose is down by 2 meters per second. Okay, so that means it needs to have a -2. Okay, and quite honestly, there's only one equation that has that, and that would be letter D. Okay, this represents going down 2 meters every second, and this represents starting up at 25. Maddie works at Game Exchange. They are having a sale as shown. Her employee discount is 15%. If sales tax is 7.25%, how much she spend for a total of 4 video games? Okay, so I am doing 4 video games, which is right here. Okay, if I buy 2, I get 1 free. So she is going to purchase 2 video games. Okay, and those will each cost her 20 bucks. Then she's going to get the third one free, and then she's going to have to buy the fourth one for the regular price of 20 bucks. So it looks like her total is going to be $60. Now she's going to get an employee discount. That means her price is going to go down. This discount of 15% needs to be changed into a decimal. You're going to move the decimal on the 15% 2 spots, so that'll be 0.15. So you're going to take this 60 and multiply by 0.15 in your calculator, and you will get that she is going to get $9 off the price. Okay, so 60 minus that $9 discount, now her total is $51. But she also has to pay for sales tax. Her sales tax is 7.25%. Move the decimal place 2 spots, and you're going to be multiplying by 0.0725. So if I round that to the nearest cent, it looks like she's going to pay $3.70 in tax. So take that $3.70 and add it back to her price of $51, and you get that her bill is going to be $54.70. Okay, 2 rectangular walls, each with a length of 12 feet and a width of 23 feet, need to be painted. It costs 8 cents per square foot for paint. How much will it cost to paint the walls? Well, if I am painting the walls, that is area. So if I'm going to find the area of a rectangle, I'm going to do length times width. That'll be 12 times 23 here, which will give me 276. But there's 2 of them. So I'm going to multiply by 2, and I get 552 square feet that I need to paint. Okay, now everyone's going to cost her 8 cents. So I'm going to multiply this by 8 cents, which is 0.08. And that should give me 52 times 0.08. And I'm getting a price of $44.16. All right, number 4, you should be able to solve on your own. Okay, so I want you to stop. Go ahead and do that. Remember, you want to move your x's together. So pause this video right now and solve this thing. When you are done, you should have this. Now, I will expect to see work when I do this for your binder check tomorrow. All right, absolute value equations. We talked about absolute value equations yesterday, and you know that absolute value equations look something like this. Okay, an absolute value, and there's a variable inside of it, and then it's equal to some number. Remember, there are 2 cases to consider. You must set up the positive version and the negative version. Okay, and there will be 2 answers. So here we go. If I take a look at number 1, the first thing I'm going to ask you is it possible for the absolute value to be equal to 10? Well, of course it is, because that 10 is positive. So if I set up my positive version, remember I'm looking at the positive version of that number, which looks like that. And then my negative version, I'm going to set up the negative version of that number, which looks like that. Okay, so go ahead and solve. We got to isolate the b. And I'm not going to do much talking through this because this should be pretty fresh in your head on how to solve these things. So there are my two answers. Let's take a look at number 2. You will see the absolute value is equal to 12. Of course, that's okay because 12 is positive. So we're going to set up the positive version of 12, and we're going to set up the negative version of 12. And you can go ahead and solve. As always, I don't care whether you have the decimal answer or the fractional answer. They both mean the same thing. All right, is it okay for the absolute value to be equal to 12? Well, sure it is. So positive version and negative version. Go ahead and solve. Now I hope that you're solving these on your own and just checking with what I have in front of you. And again, as always, it does not matter to me if you have the decimal answer, the improper answer, or the mixed number answer. All right, let's do something a little bit different here. In number 4, I want you to notice that there's stuff outside the absolute value. Here's my absolute value. I have this 2 and I have this minus 3 that are also attached to it. Before I can set up my positive and negative version, I have to get rid of those things. Okay, so the farthest thing away from the absolute value is going to be that minus 3, so we're going to get rid of that first. Then I need to get rid of that 2. It's being multiplied. It is right directly next to that absolute value, so that is multiplication. And I get that the absolute value of h is equal to 5.5. Okay, now just looking at this, you probably can tell me that the positive version looks like that, and the negative version looks like that. Notice there's nothing to solve in the positive and negative versions because the h is already isolated. Okay, here in number 5, there's my absolute values. You'll see I have the stuff outside of my absolute values that I need to get rid of. Please do not subtract the 4 and the 3. Okay, I have to get rid of them by moving them over. So this 4 is positive, so I'm going to go ahead and subtract it. The negative 3 is being multiplied, so I'm going to divide it. And I have the absolute value of d is equal to negative 2. Well, that should be a red flag to you because an absolute value cannot be equal to a negative, so that will be no solution. All right, last one here. You'll notice I've got my absolute value right here. I've got this and that around it. So the first thing I'm going to have to get rid of before I set up my positive negative versions is the 12. I'm going to subtract it. Looks something like that. Now you'll see that the p is in the bottom. I've got to get that out of the bottom. That is being divided. So I will multiply both sides. And I get 4 is equal to 2 times the absolute value of p. Now go ahead and get that 2 off of there. It's being multiplied, so we will divide. And I get the absolute value of p is equal to 2. It is just fine for the absolute value to be equal to 2. So if I set up my positive version, I get that. And if I set up my negative version, I get that. Notice there is no solving to be done there because the p is already all isolated. All right, let's try a couple word problems. I want you to pause this video right now. I want you to read it. Okay, and then restart it when you're ready. All right, the first thing I want you to do in all of these A, B, and C is I want you to cross out where it says write an equation. Okay, we are not going to write an equation. We are just going to find their fastest and slowest times. Okay, so here we go. Part A. If the first runner runs the first leg in 52 seconds plus or minus 2 seconds, that means the time could either be lower than that by 2 seconds, which would be 50, or higher than that by 2 seconds, which would be 54. So that's runner number 1. Part B. Runners 2 and 3 run their laps in 53 seconds, but now this is plus or minus 1 second. So their fastest time means it'd be 1 second less, and their slowest time would be 1 second more. So that would be that. And this is runners numbers 2 and 3. Part C, we talk about the anchor, the fourth leg. He's the fastest. He's running at 50.5 plus or minus 1.5. So if I want a faster time for him, I can go down by 1.5, which gives me 49. The slower time would have it go up by 1.5, which would give me 52, and that's runner number 4. Now, if you read this carefully, they want you to know what are the team's fastest and slowest times. The faster the time, the lower that number will be. Okay, so I'm going to take all of these lowest numbers and I'm going to add them. I'm going to make sure I put 52 in there twice because that's runners numbers 2 and 3. Okay, so runner number 1, runner number 2, runner number 3, and runner number 4. So the fastest time they could run is 2:03 seconds. The slowest is going to be their higher times. So runner number 1, runners 2 and 3 are the same, and then runner number 4. So if I add all of those fastest times, or I'm sorry, all those slowest times, the slowest possible time they're probably going to run is 2:14. Okay, last but not least here, folks, let's take a look at number 9. Go ahead and pause this video now and read it, and then we'll move on. You will notice they're giving me a plus or minus 3%. You'll also notice that we are looking where it says finding new resources for Earth, which is this slice of the pie. It says, what is the range? Now, range is highest minus lowest, and it says the number of students. Now, these are percentages in here, okay? So if I want plus or minus 3 on this 21%, if I subtract 3, that would give me 18%, so that's the lowest. If I add 3, that gives me 24%. But it says here I want the number of students, not the percentage of students. Okay, so I need to turn those percentages into decimals, and I need to multiply them by the number of people that were surveyed. So that will tell me a total number of students instead of just the percentages. And I get 1032 over here, and I get 744 over here. Okay, so that's the range of students that would have said it is most important to find new resources for Earth. Somewhere between 1,032 and somewhere down to 744. Okay, folks, so this star and this double star and triple star, you're going to complete on your own. So I want you to pause the video, and when you're finished, you're going to go ahead and pick it up and see how you did. Remember, on this one, folks, you need to be isolating the absolute value first. So I have to get everything away from the outside of it. And then I will set up my positive and negative versions. All right, folks, I hope you have a good day. Your homework for today is going to be that.